Good morning, guys. From here, we will describe our weekly plan. For this week, we will describe today what is the OCR system. What's your homework? Complete your empty questions from page 29 to page 30, till page 40. If any question you didn't answer it, you have to answer it and send it back on Scholar. And this is our online video that describe what is the OCR. Our promotion project part is creating two sets of data on one graph. The previous task, we created one graph of one set of data. This week, we will have two sets of data, and we will make one graph to express this graph. And we have an online quiz on Thursday, 14 May, from 12:30 p.m. till 1:10 p.m. We will go to our book at page 24 and see what is the OCR. The OCR stands for optical character recognition. From its name, it's optical, but in Arabic it means ضوئي. Character means characters as ABC, and recognition means understanding. So it's mainly an input device used to take the characters or capture the characters and insert it inside the computer. It's one such system that allows us to scan printed and typewritten or handwritten text, like numerical letters samples, and convert scanned image into the computer, able to be formatted, either format of a plain text or Word document. So it's an input device. It's like the scanner, but it's mainly scanning the characters and inserted as data inside my computer, or mainly inside my Word document. We'll go to see the video, and then we will have a small video about your promotion project this week.
You know, it's pretty easy to take words on your computer screen and put them on a physical sheet of paper. Just click print, and unless you've forgotten to fork out an extortion level amount of money for a new cartridge, you'll have fresh, warm, satisfying documents just a few moments later. But going in the opposite direction, scanning dead tree information into your PC is actually quite a bit trickier. I mean, sure, flatbed scanners aren't all that difficult to operate per se, but many of them are basically just taking a picture of the document and saving it onto your PC.
As you hear, this is the difference between the ordinary scanners and this scanner. The scanner mainly takes an image for the paper, for your paper, and insert it as an image. But here he is recognizing, taking the image and recognizing each word inside it or each character inside it and convert it into text.
Meaning not only will it probably not look very crisp due to file compression and little bits of dust in your scanner, but you can't edit a clean copy of your document in your favorite word processor because the scanner won't recognize each individual character. Fortunately, there are a number of devices out there that enable optical character recognition, or OCR, where each character on a page is scanned individually, so your papers are uploaded as actual text documents instead of messy JPEGs. But how exactly does that work, and is one kind of optical scanner better than another? Well, because the whole concept of translating text into electronic signal is pretty broad, there have been lots of different implementations of OCR over the years. In fact, one of the earliest electric OCR devices, the optophone, was invented all the way back in 1914. This bizarre-looking contraption relied on these special behavior of selenium, which conducts electricity differently in light and darkness. As it scanned the words on a page, the optophone distinguished between the dark ink of text and lighter blank spaces, generating tones that corresponded to different letters, making it possible for blind people to read with some practice. Later, in 1931, a machine was developed that could convert printed text to telegraph code, one of the first technologies to translate printed characters to electrical impulses rather than sounds. But it wasn't until the 1960s and 70s that OCR began to take a more familiar modern form, with postal services using OCR to read addresses and software that could recognize many different fonts. So back to present day. When you scan a document, how exactly does the software know what it's looking at? Well, the first step is to cut out artifacts so your OCR program can concentrate on the text and nothing else. So it attempts to remove dust and other various graphics, align the text properly, and convert any colors or shades of gray in the image to black and white only, making the words themselves easier to recognize. The next step is to figure out which characters are on the page. Simpler forms of OCR compare each scanned letter, pixel by pixel, to a known database of fonts, and decide on the closest match. Smarter OCR, however, takes this step farther by breaking down each character down to constituent elements like curves and corners, and looking for matching physical features and actual letters. You can think of the differences between these two approaches similarly to the difference between raster and vector images, which you can learn more about up here. OCR software can also make use of a dictionary so it won't accidentally spit out nonsense words due to inaccurate scanning. For example, if your scanner sees this, but it can't quite tell whether the middle letter is an O or an A, it can check its own dictionary to decide that the word is actually dog and not dag. Giving OCR software situational information can further cut down on errors, such as telling it to only try to match numbers if it's reading zip codes on an envelope.
So, how it works? We are placing our machine, our OCR, each character. He goes to each pixel or to each small part of the word. For example, if it's this 2, we will start from this part to he will move like moving my cursor here to scan each black or dim part inside my words until he recognizes that this is number 2 or recognize this is number 8.
Even with these tricks, however, OCR obviously is not perfect, which you've probably seen for yourself if you've ever used it. But with greater processing power and machine learning techniques that allow software to recognize more subtle patterns over time, OCR has become versatile enough to recognize harder to read typefaces, inconsistently printed material, and even handwriting. And free OCR cloud processing services like Google Drive, which has a lot more machine learning capability than your home PC, for which I hope are fairly obvious reasons, have made OCR more accessible than ever. No word yet, though, on whether Google will take it a step further and launch Google Interpretive Dance Translator. I don't know what I'm doing. Ignore me. Are you racing against the clock as a freelancer, trying to start your challenging but rewarding interpretive dance company? With the growth of the internet, there's never been more up.
We'll continue the other video.
Today we're going to take a look at OCR, or Optical Character Recognition. OCR is the technology that converts printed text into a digital format. The variety of different fonts and ways of writing a single character makes this problem hard to solve. Before an OCR algorithm can be chosen, the image must undergo some pre-processing. In this step, the document is straightened, despeckled, and converted from color to a binary image, an image where the only two colors are black and white. The feature detection algorithm identifies identifies a character by analyzing the lines and strokes that make it. The second approach, pattern recognition, works by identifying the character as a whole. We can identify a line of text by looking for rows of white pixels with rows of black pixels in between. In the same way, we can identify where an individual character begins and ends. Next, we convert the image of the character into a binary matrix where white pixels are zeros and black pixels are ones. Then, by using the distance form,
this is the binary code the computer understands, which is zeros and ones. We have only two numbers inside my computer. Those are the binary codes, zeros and ones. All the damned one, the black one, will be ones, and all the white one will be zeros. To define the shape of this character.
Formula, we can find the distance from the center of the matrix to the farthest one. We then create a circle of that radius and split it up into more granular sections. At this point, the algorithm will compare every single subsection against a database of matrices representing characters with various fonts to find the character it statistically has the most in common with. Doing this for every line and every character makes it easy to bring printed media into the digital world.
We can search here for the shape of an OCR to let you see it, or we can, in another way, search on Google. That will be more accurate. The shape of an OCR machine, and we will go to our screens. This is mainly the shape of my OCR. This is an OCR. It's it's handled by your handheld, and see it, and you will place it on the word, and he will read all those words and convert it into data inside your computer or your Word document or your notepad, whatever software you are entering the data inside. We will go back to our promotion project. This is the part of this week is creating two sets of data on one graph on the Excel. This is the last part of my promotion project. We will go to our previous scanned video of how to make graph of two sets on the same graph. You have to concentrate in this part to not be
This video shows you how to use Excel to plot two linear data sets on the same graph. So sometimes you might have data that you would like to compare. So for example, here I have some information on metal A, masses of the sample versus the volume of the sample, and the same kind of data for metal B. And I would like to plot mass versus volume for both of these metals on the same graph to compare them. So let's do that one at a time. So we're going to select one set of data. So I'm going to click and drag to select that set of data. I'm just going to do the data set right here. And then we're going to go up to the Insert menu right here. And we're going to find the Charts area. And then we're going to click on this little button for XY scatter graphs. And we're going to select this one that's just the dots. There we go. So there's a graph. It's inserted it. It needs a little bit of formatting, but we will take care of that. First, we want to make sure the data looks like what we want. So it looks like it's plotted mass on the x-axis and volume on the y-axis. And that's kind of like the way I have it laid out here. But you know what? I think I would really like volume to be the x-axis and mass to be the y-axis. So anytime you want to change something about your data set that's plotted or add some extra data to a plot, where you need to go is the Chart Tools, Design tab, and the Select Data button. So Select Data is your home base for changing anything you want about the data and the way it is graphed. So we're going to select the data here. That brings up a dialog box. So if we select this first set of data, volume 1, and we want to change something about it, we're going to click Edit. So first is the series name. So this is where it's getting its name, and apparently it's named at volume. Well, that's not very useful. So let's call it perhaps metal A. So I can do that either by typing it in, MET like that, but I can also get it by selecting a cell that is labeled. So that's what I'm going to do. I'm going to click on this little button right here, and it's asking me to input the series name cell label. So I'm just going to go over here and click on that, and it selected that cell as our new series label, the series name. Next, I want to select the X values. So right now it has A3 through A8. If you click on this cell, it will show all that to you. But what I want to do is get rid of all that and change that to cell B3 through B8. So I've done that. There we go. And now I need to select this set of data, so I'm going to click on this button right here, go over here and make this, the mass data, my Y values. So there we go. So now I've changed the X and the Y values, and that all looks good. Here's some data now. So I'm going to click on OK, and that takes us back to this dialog box. Now we would like to add our second set of data so that we can compare it. So how do we do that? Well, we just click on this Add button right here. That will let us add a new data set. So this is asking us to edit the series. So what's the series name? Well, I'm going to select the metal B cell right here. Click this button to return. We need to select the X values. So the X values are going to be volume. Click to return. The Y values are going to be mass. And click to return. Now we should see, yes, 2 linear data sets. So that looks great. We're going to click on OK. And there we go, back to this dialog box. And now we're going to click OK. So now we've got the 2 data sets plotted. Let's do a little bit of formatting. So I'm going to go up here to the Click Layout tab. And you can pick any of these layouts. I kind of like this first one as an option. So it gives you a chart title, axis titles, and legends, and then it just shows you horizontal lines here for these different levels. So I'm going to double click on this axis title and select all of that and change that to mass. Always give it a unit in grams. Then my x-axis title, I want to select all that, and we're going to call that volume. And give it a unit label, milliliters in this case. Good. So the last thing that I need to do, since these are linear functions, let's go ahead and find the equations of the lines that pass through these data points, and also draw in the line so it's easy to see what's going on. So I'm just going to point my...
Enough for here. This is one way of how to creating a graph. I will see another way inside your book. From here, first you will select the 2 sets of data you want to appear them inside your graph. Second, choose, go to Insert tab, choose it, and select Recommended Charts in the chart group. Then select all charts, choose Compo, and then choose the default type in each one, which is clustered column line. Then choose the type of your chart you want to use as your secondary axis. And the last one, press OK and save it and send it on a Scholar. I will go to make one of like this one. I will delete it from here at first. That's step number 1. Select on the 2 sets of that. Select on the 2 sets of that. Second one, go to Insert and choose Recommended Charts. Number 3, choose all charts, then choose Combo. Make those 2 chart types clustered column, and this is clustered column, to see both of them like this shape. And press OK, and here's the chart appeared here. You will save it and send it on a Scholar. I'm very glad to see you here. If you have any questions, I'm hearing you. Thank you.